Right. So last but certainly not least, we have one more skill to learn is this part of the course. And that's weighing a molecule, right? So our molecules are made up out of matter, right? They're made up out of atoms, and matter has mass. And so if we have two different compounds, they will weigh different amounts, right? That makes sense. A molecule of water does not weigh the same as a molecule of oxygen or something like that, right? All of that should make a relative amount of sense. And then our mass of our atoms are located on our periodic table, right? So hydrogen, for example, we can take a look there. It has a weight, or hydrogen weighs 1.008 AMU. And our AMU, if you think back to the beginning of this course, was an atomic mass unit. Later on, we're going to call this as grams per mole, and we're going to call this the molar mass. But for right now, we're just weighing an individual molecule. Another example, right? Carbon has that mass right there. So carbon weighs 12.011 AMU. And then what if I asked you, what about the mass of CH4? Well, if you think about it, CH4 is made out of 1 carbon and 4 hydrogens. So it's going to weigh as much as 1 carbon and 4 hydrogens. So what we want to do to figure out the mass here is we want to have the number of each element that we have times the mass of that individual element. And we do that for every element in the formula, and then we add them all up. So for example, here we only have 1 carbon and it weighs 12.011 AMU. And then on hydrogen, in this case, we have 4 hydrogens and they each weigh 1.008 AMU. And so then we just plug that into our calculator and we get 16.043 AMU, right? So you just take the weight of each individual atom, multiply it by how many of those atoms there are, and then add them up together. Be careful here, there can be a little bit of tricks here. So for example, calcium nitrate. What's the mass of calcium nitrate? So first of all, you have to go from the name to the formula. So we know that calcium generally goes 2+, nitrate is NO3-. So if we think about the formula, we have to say calcium and then in parentheses NO3, and there has to be 2 of them to balance out the +2 charge of the calcium. So let's go ahead and take a look at how much of each one of these weighs. Calcium is right over here weighing at 40.078. And there's only 1 of them, so we just have to multiply that by 1. Next up, we want to think about how many nitrogens there are. So there's 1 nitrogen per nitrate, but we've got 2 nitrogens, or 2 nitrates. So that means we actually have 2 nitrogens. So in the case of nitrogen, we'd actually multiply 2 because we have 2 of them. And then we use our periodic table to find the mass. Nitrogen weighs 14.007 AMUs. And then finally, we think about oxygen. We have 3 oxygens per nitrate, but we have 2 nitrates. And so if you think about that, that's for a total of 6 oxygens. And then you take a look at a periodic table. Each oxygen weighs 15.999 AMU. So we want to take 6 times 15.999 AMUs. And then we type that into our handy dandy calculator and you get 164.086 AMU. Later on, we'll call that grams per mole. But yeah, so basically you need to be able to know the mass of a molecule. Shouldn't be too difficult, but definitely do some practice. This is going to be an extremely important skill for later on in the course when it gets real mathy.